Hello, this is Captain Steve Tarrant from Maine Maritime Academy with another video lecture from NS301 Stability. In this short video, we're going to just discuss briefly the difference between the angle of list and the angle of loll. So first we're going to look at angle of list. So take a vessel floating in the water. Here's your keel down at the bottom. There's your center of your metacenter at M. And here you can see G is below M. So this is a vessel with positive GM. And since G is on the center line, the vessel is in the upright condition. But what happens if we were to put a weight, let's say, this is the stern, we're looking at the stern of the vessel here. Let's say we put a weight, and by the way, the force of gravity is being counterbalanced by the force of buoyancy. That's why the vessel is floating in the water. They're equal and opposite. And right now the vessel is at rest. Buoyancy is directly below gravity, okay? But if we were to put a weight, let's say, over here on the starboard side, the center of gravity would move off the center line. And you can see that the vessel would incline. Okay? The vessel is inclining, okay, because there is an upsetting moment here. Okay? B and G are separated by a distance. That distance is the righting arm, GZ. But in this case, this is not, in fact, a righting arm. All right? It is an upsetting arm. And we call it upsetting because the vessel is inclining from the center line, and it's inclining in a way that we don't really want it to go. But so anyway, there we have it. Okay. Now at this point, the vessel stops inclining. Why? Because B and G are in vertically alignment again. Now I couldn't get it perfect in this PowerPoint, but just assume that green arrow is exactly in line with the red arrow. Okay. So now, interestingly enough, if the vessel's at sea under this condition, and let's say it takes a roll of 10 degrees, it'll roll 10 degrees to port and 10 degrees to starboard around this point. Okay? So the vessel will roll around this new center of gravity. We would much prefer it to roll around a center of gravity on the center line. Why? Because if it already starts at 10 degrees, we're 10 degrees closer to deck edge immersion on this side, which is not a good way to start off your voyage. But anyway, how could we correct this? Well, we could move an equal weight on to this side, or we could move a greater weight. Anyway, we could move some combination of weights that equals the moments of this to the other side. Or we could just remove that weight altogether. Let's see what happens if we do that. We remove that weight. Oh, look, center of gravity goes back into the center. Again, we have a moment. Okay? The upward force of buoyancy and the downward force of gravity are separated by a distance. Now, in this case, this is a righting moment. Why? Because the vessel is going back to upright. And the vessel will come to rest again when those are back in line vertically. And please, give me a little forgiveness here that these are not exactly in line. It's an issue with PowerPoint. Okay, that is angle of list. And again, if you have an angle, so in this case we have no list because G is on the center line. But if G was off the center line, the vessel would then roll around that off-center G, which would be dangerous, or could be dangerous. Okay. So now let's look at angle of loll. Angle of loll is different than off-center center of gravity. Okay. In angle of loll, the center of gravity is on the center line, except it's above M. For angle of list, G was below M. We say that is positive stability. In this case, G is above M. We say that's negative stability. Well, this is undesirable because it can lead to this thing called angle of loll, where the vessel could flop from one side to the other. Let's look at how that might happen. Okay, we're going to remove M because at angles of inclination greater than 10 degrees, M starts to move, and it's going to complicate what we're trying to do here. So we're just going to focus on gravity and buoyancy. So gravity works down, buoyancy is equal and opposite working up. There are two vectors. Now what we're going to do is we're simply going to bump this vessel on the port side. Again, we're looking from the stern. We're going to bump it on the port side. We're not going to apply a force continuously. We're just going to, as if a tug came up and bumped it, or a wave came up and bumped it. And we're going to see what happens. Okay, there was that force. Now look, as the vessel is inclining, buoyancy is not in line with gravity anymore. All right, at this point. The vessel inclines, and you see, again, we have this upsetting moment. We have this upsetting righting arm here, okay, GZ. All right, this is pushing up, this is pushing down, that's creating a torque. And the vessel will incline until they are back in line, in alignment again. This is called angle of Loll, okay, and now there is no righting moment or upsetting moment, and the vessel comes to rest at this new angle, which is called the angle of Loll. Well, what happens if we were to bump the vessel back from this side, either by a tugboat or by waves? Okay, boom, we bump it. Well, look, again, the forces separate. So we have a righting moment until we get to this point, but at this point, we then end up with an upsetting moment until the vessel goes to the same number of degrees on the port side. So let's say we had been inclined to 10 degrees on the starboard side. Now we're at 10 degrees on port, and the vessel will come to rest here, perhaps. Okay? Well, very good. Well, you might think to yourself, if I want to correct this, I want to get the vessel upright again, I should probably put a weight right here. Because if I put a weight right here, that's going to make the vessel come upright. Well, it will, but it's going to complicate and make the vessel even more dangerous than it already is. Because what we're going to do, if we were to put a weight here, is we're going to have all the problems of angle of Loll, and then we're going to have all the problems of angle of list created by an off-center weight. And they're actually going to add together and create even a greater angle of Loll. Let's just look at that. All right, so here we are. If I put a weight there, now I have not only do I have a high center of gravity, G above M, but I also have center of gravity off the center line. Let's look how far the vessel is going to incline as we come to this side. Whoa, look at that. We're almost at dead edge immersion now. Okay, this is much worse than it was before. Do not do this. Okay, if you're on a vessel and the vessel is inclined and you're not sure if it's inclined because of Loll or perhaps because of off-center weights, you have to assume it's Loll. Otherwise, you could end up in a very dangerous situation with your vessel. So, angle of Loll occurs when G is on the center line and above M. If you shift your weights transversely, you'll create an angle of list as well, and those two will sum, creating a greater, larger angle of inclination, and this is incorrect and dangerous. Don't do this. So, how should you do this? Well, we should ballast down. If we ballast down, we're going to lower the center of gravity. All right, now, as soon as the center of gravity is lower, as G comes down the center line, all right, that is going to create our righting moment. And the vessel is just going to start to right itself until B comes back underneath G, which will happen when B is back on the center line. So let's watch that. And the vessel comes back to rest. If we can get G below M, then the vessel will be back at rest, and we're in the upright condition, and our problem is solved. So again, arriving at a vessel that is inclined, you don't know if it's because of negative GM or angle of list. In that situation, you should be conservative and assume that it's because of angle of Loll and ballast down the vessel. If when you do that, the problem resolves itself and the vessel uprights, then you know that was the problem. If it doesn't, then you know that it's off-center weights, and then you can move weights around. Thank you.